Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and today we are programming. Specifically, a tutorial on how to implement, how to implement cat in Pure Bash, as you see up there. Although the goal here isn't really to implement cat. It's more of this is what we're going to be using as a delivery mechanism to show you how to program in Pure Bash. Because if the goal is cat, this is pretty much it. Stream over. Well, anyway, I hope you're all doing well. Today, what happened to work today? It's a half day because Canadians have the day off on Monday. Stream over. Good night, indeed. Yeah, Canadians have the day off on Monday because it's Canada Day. I know any Americans here, you have Thursday off for your Independence Day, but we have Monday off. And my workplace, whenever we have a long weekend, does half-day Fridays. Although I still have some HR reviews to do. It's it's the end of the half of the year, so they have us doing peer reviews and self-reviews, and I still haven't done those. So I'm probably going to be working a little bit before Tuesday, or before the end of the month, because it's actually due June 30th. But it happens. It's fine. I'm pretty slow when it comes to writing stuff too. So hopefully it won't take me too long. A lot of it is probably just copy and paste from last time. But anyway, going back on topic, this is the repo that we're going to be working in. It is linked in the Twitch chat and over on YouTube. It's linked in the description. So if you'd like to follow along, I will be pushing to this repo periodically as we finish the steps. And if you would like to follow along in your local environment, just have a bash environment ready and a text editor, and you're good to go. In addition, we're also going to be using bats over here for automated testing, just so we know that whatever we do is still good after each step. Because it's always good to make sure your stuff is tested. Okay, yeah. So a quick explanation of what bash is. If you're ever in a terminal, for example, this one, on a Linux machine, you're generally going to be put into a bash shell. There are other shells available. Z shell is a common one. That's actually the default one for Mac these days. It used to be bash. But bash is a shell-compatible shell, SH-compatible shell. And SH, the Bourne shell, is the command line interpreter for the original Unix. You'll find that a lot of the shells these days are Bourne shell compatible, but not all of them. One classic one that isn't Bourne shell compatible is the C shell, and then another one that is somewhat popular these days is the fish shell. Fish shell is fairly user-friendly, a lot of nice interactive stuff. I don't use it myself, but I know a few people who do. The Bourne shell here is specified in POSIX. Was this large document here. POSIX basically is the documents or the specification that specifies common portions so that things are interoperable with each other between the various Unix or anything that between anything that is POSIX compliant. You're guaranteed to have that interoperability. Finally, command line shell for the 90s. Yes, I believe that is the fish shell's tagline, because the Bourne shell was made in 1979, 45 years ago, and so we're still adhering to that compatibility standard today. And then Bash itself was out starting in just before the 1990s, in 1989. Now, should you be doing any serious programming in Bash? Probably not. I probably use Bash a bit too much because I find it very comfortable to work in Bash and the shell in general. But for serious, like, production grade things where you're doing like major logic things, probably not. Maybe stick to Python for that. Actually, that's probably another reason why I don't why I work in Bash a lot, because I don't know Python. Nor do I know Perl. And Node is kind of awkward. I don't know. Node feels a bit awkward to use as a scripting language. Okay, so we're gonna start with this one. We're gonna clear off this, and we're gonna start from scratch. So every Bash file, every Bash script should start with what's called a shebang. Oh, I didn't know that would autocomplete for me. User, bin, and bash. This is the proper shebang that you should use. You'll often also see bin bash, like this one. Well, this will generally work, but the reason why you want to use this first one instead is because then it searches your environment for the bash executable. Sometimes it's not going to be in bin bash. Sometimes it's going to be in user bin bash. And if that's the case, this is not going to pick that up. On Arch Linux it will, because /bin is symlinked to user bin. So it does actually exist there, but it's not always for other systems. So then this allows you to execute the file as a script, rather than giving it as a argument to the bash interpreter. And so this will allow us to I have this in bin/cat. It'll allow us to execute that directly as opposed to doing bash this. And so what the shell does is, if it sees a shebang, it will run this command and then add the file afterwards. By the way, if you feel I'm going too fast, feel free to tell me to slow down, or if anything is confusing, ask away. This is a learning session, so I do want to make sure that everything here is clear. Okay. So a primer on the cat utility. We're gonna do man cat. What this basically does is concatenate the files and print them to standard output. And if you don't give it any files, it takes in standard input. So we can show that here. Say we do cat, right? Now it's waiting for inputs. We type some stuff. This is going to go into standard inputs, and then it gets written out to standard output. Once again, we get a line, and we get another line echoed back. However, if you give it a file, let's say the license file that we have here, right? A common way to see the contents of a file in your terminal is to use cat. So say we cat out the file here, then we get the file contents out in the terminal. Cat also allows you to specify multiple files. So let's say take the README. And that's the reason why it's called cat, right? Because it's concatenating the files. So we should first expect to see license, and then we expect to see the README. All right, so we have the license here, and then immediately after we have the README. And you can have an arbitrary number of files on the command line. And it'll concatenate them all for you. Okay, so we're going to start with the very basic case where we have a standard input, and then so that would be this case here, where we just call cat, and then we echo out what we have in standard inputs to standard output. And so what do we do here? Man, I should have, to be honest, I should have brushed up a little bit. I used to do this this as a lunch and learn for work, but it's been many, many years since I've done it. Okay, so what do we do? The meat here is going to be the read utility. So read is a command, built-in command to Bash, that takes in input from a file descriptor, by default standard input, and then puts all that content into a variable. So in this case, we're going to do read r, and then we're going to call this line. The line here is going to be our variable that we want to put it in, and then r here just says don't interpret any backslash escapes. So this we expect. Don't worry about that. Actually, no, do worry about that. So this we expect to read one line from standard input, and then we're going to echo that out right away. And so we're going to use printf for this. You will see in other scripts echo, but in cases where you're using user input, you want to be using printf because it's safer. So we're going to have here printf, and then I use single quotes for printf. There is a difference between single quotes and double quotes. I will get to that in a bit, but in this case it doesn't really matter. And then if you're familiar with the printf function in C or other languages that have printf, this here is a formatting string. But the %s basically says output the thing as a string. And then we have \n, which will give us a new line. And then we are going to put in line here as the variable. So in Bash, variables, when you access them, you use the $sign in front of the variable name. So this is analogous to calling a function almost. So you have printf being the function name essentially, and then the two arguments to the function, you have the formatting string, and then the other arguments to it. So what we should expect to see here is that we are able to read one line, and then have it echo back out. Well, let's maybe put that over here. So we expect to run bin cat, run it. It should wait for standard input. We get something from standard input, and we get it back out. Okay. So now we can write a test around this, and maybe we should have written a test before that. So we're going to put that maybe up here. As I said earlier, we're going to be using bat to do our tests. Cat.bats, user bin and bats. So this is something that you generally do install. Although there is a way that you don't have to install it, and you can put it right in your repo. And then bats uses this this special syntax at test, and then we give it a name. Reads one line from standard input. So we're in test dots. Yes, we're in test. We actually need to go up one, and we go to bin/cats.sh. Not sh. We don't have that. So bin cats, and then I'm going to. Sorry, I hadn't really thought about how to test up set up this test. So I'm going to do a couple things here, just specifically for the test. We can define a setup function where we can create a temporary directory. So we're going to call this temp dir. or I'll call it test dir, I guess, equals make temp dash d. I'm going to gloss over this because it's kind of outside the scope of the tutorial. But essentially here we're creating a temporary directory so we can dump files in. In bats, you can also define a teardown function. And then this will run after every test. So the setup function will run before every test, so we can do whatever we need to make sure the test can run. And then the teardown can clean up after the test is done. So in this case, we want to get rid of the temporary directory so that we aren't leaving random files around. rmrf test dir. Again, glossing over this, but basically it forces the removal of the directory. So what this means then is that we can so I guess we don't actually need that, but that's fine, we'll need it for later. Actually no, we do need it. Okay. So I'm going to gloss over this bit. We'll explain that in a bit because I think we will be using it later. But essentially what we're doing is we're feeding in as inputs ASDF, the string, and then we are going to send this to a file. That'll be test dir slash out. Sure, let's call it out. And then we use diff. Diff is a utility. Again, this is out of scope, but we have the diff utility. Actually, no. Let's put this into a file. Test dir slash in, and so we can slash in. I assure you this will be a little bit more coherent once we get started. But if anyone's confused, please do speak up, and we'll try to explain more. Test dir slash in, and then test dir slash out. And so basically what we're saying here is that we want to write our test inputs to a file called in, and then we want to use our cat utility to feed that file into standard inputs, and then write the contents of that file, or write the output of that file, that command, to a file called out. And then we're taking the difference between the two and we expect them to be the same. If they aren't the same, then diff will fail. And then we can ignore that because for some reason shell check doesn't quite work with bats. It's supposed to. But then we can run test slash cat.bats to run our test file. And then we are failing. Okay. Right, because then we can just do this then. .bin, because we are in the current directory. At the root of the directory. Root of the repo. Okay, there we go. We have it passing. So we know that our cat utility prints can do one line. So that is a commit. Oh no, I didn't mean to do that, but status git diff cached. We should expect to see both of these lines here, both these files. Okay. So we can commit that, git commit -m read read one line from standard inputs. Okay. Now how do we read multiple lines? We can copy our test here. reads multiple lines from standard input. And so we can have another set here where we're going to add multiple lines to the file, like so. Now we have 3 lines in this file: ASDF, QWERTY, and then ZXCVBN. And then we do the same insertion here, where we feed the file in, and then we expect to get it out. So in classic TDD fashion, test-driven development. Sorry, I'm supposed to push this too. Git push over here. Because one of these has me already authenticated. Okay. So in classic TDD fashion, we should test this out. And we should expect it to fail, because we haven't done anything yet. And so, what we can do is, instead of just reading one line, we can read multiple lines. And we can do that in a while loop. So Bash has a number of loop constructs, most notably while and for, but we can put this in a while loop. So read will succeed until it hits the end of the file, or runs out of inputs. They're fairly equivalent. So you can say that while read our line like this, do, and then done, and we'll indent that. So the structure of a while loop here is that you have the while keyword, and then some commands, or multiple commands. In this case, our command is read, and then we can, and then what are equivalent to, say, braces in C-style languages. For the while commands, you open up with a do command, and then you do, and you close with done. We have a semicolon here because we have to terminate this command. Commands in Bash can be terminated by either a semicolon or a new line, so it would be equivalent to do it this way and format it this way. It's just I find that it's a lot more compact to use the semicolon. So that's what I do. But the other way is also valid. And then in the loop body, we have our previous print one. So we have this, then we can test it out again. And now we can read multiple lines. And just to show this in action, just so it isn't just a test, bin cat. Right. Put in all sorts of lines here, and it continues to read and echo. Oh, but we got I don't think you can see that. Hold on. We got a little bit of a bug here. I have some white space. That's tab, and then some text here, but it didn't echo that out. We should fix that. But first we'll commit, because this is committable. So git add -p. Move this over here so you can see better. This is fine. This is fine. Git commit -m reads multiple lines from SDIN. Okay, so how do we fix this? There is something peculiar about read, and that read can actually split things up into columns, and put all the columns into separate variables. So, for example, if you had, put this over here, say reads -r a b c, and then you give it, say 1, 2, 3 like this. In variables A, you get 1. Variable B, you get 2. You get variable C, you get 3. And the way it knows to be able to split this up is this variable called IFS. IFS, the internal field separator. I don't know if we're going to be able to see this. Yeah, that's pretty hard to see. I'm going to put this through XXD or hexdump. And we see that we do have a number of characters that are in here. First is 7C, which is the pipe that we had, and then 20, which is a space, 09, which is a tab stop, 0A, which I think is the new line, and then 7C again is this this pipe here, and then we have another new line. So we have 3 characters in IFS, and again, IFS meaning internal field separator. This is what Bash uses to know what delineates columns, or fields, as they say. And so read will ignore any white space, because IFS is full of white space. It will ignore any white space that's inside at the beginning, and then process everything after that. Alright, so echo A, we still get 1, but there's no white space in front. We can change IFS. I'm going to do this in a subshell, so I don't mess with things. So if we say IFS is dots, right, then we do the same read thing. Read ABC, and we say A dot B or 1.2.3. Then, because the field separator is dots, we actually expect it to split on the dots. So we do echo A, we see 1, echo B, we see 2, and echo C, we get 3, because we're splitting on the dots. If instead we had spaces like we did before, A actually gets all of this, because we have no dots. And then the rest are just empty because there's nothing there. Alright, I hope that was clear for IFS. And so, what this means is that for read, we can say that we have an empty IFS. Let's do that again. We have the empty IFS. And this is, by the way, how you set a variable, the contents of a variable. Everything after the equal sign up until the next white space, unless you quote it, is going to be part of the variable contents. So then we do, say, read ABC 1, 2, 3. In this case, we're saying that there are no field separators, so we expect to see that everything is in A and nothing else in the rest of them. So 1, 2, 3 here, like that. And then nothing else in B or C. Like so. And so we can do that in our case, right? Because we want the entire line. So we can add IFS equals there so that we have an empty IFS variable, and so it'll take the entire line. So the syntax here is actually a little bit special. So earlier I did IFS equals this, and then started a new command for read. IFS equals that, and then read whatever. Right, but if you only want this to take effect for a single command, what you can do is you can put the environment variable assignments first, and then the command right after. So we have here IFS read ABC 1, 2, 3. Right, remember that our IFS was empty, but we can set it to dot temporarily here. And then we get echo A, we get 1, But if we echo IFS, and we're going to put this in pipes so that we can see it, we still get empty. So the IFS equals dot did not carry over. So that's what we're doing here. Because generally, if you're messing with IFS, you don't want it to persist, because that spells bad things. So you want it to be as temporary as possible. And in this case, we only want it to take effect for this this specific line. Okay. So we can write a test for that. Actually, we should write the test first, so we can see it fail. At test reads white space. Read lines with white space in front. Lines starting with white space. Bash variable assignments are something else, man. Yeah, they do take a little bit of getting used to. But once you're used to them, they can be fairly convenient, I think. I don't know how it compares to fish, but yeah, there's certainly different compared to more conventional programming languages like the C-like ones. So we can echo a bunch of spaces and then something there, and we can do sdir/in bin cats, do that same thing, and diff, and we do that. Fish just has a set command that lacks special syntax. Alright, that's fair. I think bash does have a declare command that does something similar. But yeah, setting variables is certainly more flexible, I think, in bash. Okay, so we expect this to pass. Actually, no, we expect this to fail. Because we haven't done anything yet. So now we can put in our fix here. While IFS equals that. Right, and then we should expect that to pass. And we can prove that to ourselves by testing it out. Bin cat. Right, if we do what we did earlier, we put a bunch of spaces in front, and then we do that, we should expect to see the spaces there. Though before that, they already had an env command for accomplishing the same thing. They recently added the var equals val cmd syntax for pseudo compatibility. Yeah, so bash actually has env as well. I think this is a built-in, or maybe not. Yeah, I know env here is an external application too. So env allows you to spin off a command with a specific environment variables in place. But this only works for external commands. This doesn't work for built-ins. For built-ins, you have to use the syntax here. Now, in what cases should you use env versus the special syntax? I don't know. Perhaps where you're shelling out from another programming language or something. But if you're in a shell, I don't really see much of a point for that. So we're going to commit this. Supports white space at the start of the line. Yeah, that's fine. We're going to push this. So I'm going to do it here, so I don't have to keep switching things. Just gotta grab my password. Alright, there we go. You could push. So that should be up now. And honestly, if we wanted to stop there... no, we're not stopping there. This is effectively what we ended up with at the start of the stream. This is what's in the thumbnail, I think. Yeah, this is pretty much what's in the thumbnail. So like I said, stream over, we're done. But there's a bunch of stuff that we could do too. Remember what I said that cats can take in multiple files. So let's say we cat out the license and the README, or actually even one file to begin with. If we try to do that with our utility, we can't do that. We can do bin cat and then license here, and it just ignores it. So we want to fix that. We want to be able to take in files. Bash, what it allows us to do, I'm actually going to write the test for this first. Reads file from first argument. And so we can get rid of this this input redirector, like so. So now we're giving this in file as the first argument to cat, rather than saying that the contents of the file should be redirected as the standard input for the file or for the command. We're still redirecting the output of cats to the out file, but that doesn't need to change because cat so far cannot be instructed to output to a file, and I don't think standard cat can do that either. Okay, so we do test. And now it's stuck waiting for input, which is not good. So what we want to do is we want to make sure that we can recognize the command line arguments that we get. So in Bash and other Bourne shell compatible shells, command line arguments are held in special variables $1, $2, $3, and so on until $9. There is no $10. If you try that, I think it'll fail. Or maybe they fixed it in newer versions, I don't know. But traditionally you only have up to 9. And you can still have more than 9 variables. But you'll have to shift them out and process the other ones. So what we can do here is that we can take $1 and feed it in as input to this while loop. So if you remember the input redirector that we have from before, instead of putting it here, we're going to attach it here to the while loop. Now we want to do it here because instead of over here, as feeding it directly into the read loop, or sorry, the read command, is because we want it. If we do it this way, this gets reset every time we run the loop. So every iteration this gets reset, and we always get the first line. But if we do it on the while loop instead, this persists throughout the entire loop. So it sets it up once, and then we read through every line of the input. If that makes sense. Hopefully it does. So with this, we are now taking the so $1 contains the first argument. In this case, it will be a file name, and this will be our in file. And we should expect to see that we can indeed read from the in file. Actually, we're going to have multiple lines as well. I'm glossing over this, although actually it's probably important to mention this because we won't encounter it in here. So notice that there is a difference between a single redirect and double redirect. The single case here means replace the contents of this file, and then the double redirect here says append to the contents of the file. So if you want to completely wipe it and then replace, you go with a single. If you want to keep the contents of the file in place and then only append to it, you use the double one. Because if we use a single here, then the only contents of the line is going to be this one. We want 2 lines in there, so we do this instead. Okay, so we should expect to see at least this case pass. We do see the rest of them fail, and that makes sense because we are no longer reading from standard input. So this now passes, but the rest of these fail. This is great. This is what a test suite is for. So we can test this out for ourselves. bin/cat say license file, right? It cats out the license file. Great. But if we leave that off, then we get cat line 5 no such file directory. Line 5 being this one. $1 if there isn't any argument at the first position, then it gets expanded to the empty string. And the empty string is not a valid file or directory. So it can't read it, and we get this this error here with such file or directory. How do we fix this? Well, what we can do is we can say that we can do if there is a $1, then we do something, and if there isn't a $1, then we do something else. So let's say let's maybe have a variable. Actually, no. Let's refactor later. Well, we can say that if there is an if statement in Bash, and that's called if. And then it takes in a command. In this case, we're going to use the double bracket command for testing. I'm just going to fill out the rest here. So similar to the while loop, the if command takes in commands, and then once the commands are over that you want to test, you issue the then command, and then you end with fi. So the convention for Bash and other Bourne shell compatible shells is that commands, built-in commands like these that are compounds, close themselves by reversing the name. So if becomes fi. Now the reason do isn't od for the end is because od is already another command, and they didn't want to conflict with that. Od here being the dump octal. I guess that would be octal dump, wouldn't it? Yeah. So they had to come up with something else, and do and done seems pretty nice, or pretty fitting, so that's what they went with. So looking at this double bracket syntax here, this is a special built-in for Bash. With built-ins, you can use the help commands, and it'll give you help output for that command. So here we have execute conditional commands, and so we have all this stuff. I'm gonna gloss over that. You may see in other scripts the single bracket test, and this is more traditional Bourne shell. Double bracket here is specific to Bash, and it's less of a foot gun than the single bracket, because there are some nicer safeties around this one. Most notably that the inside is treated more like Bash, whereas with this one, this is an actual command. If you do this, right, this is an actual command. In Bash, this is actually implemented as a built-in, but you can, if you really wanted to, you can disable the built-in so that you can use the actual external command instead. But both of these are essentially so we do help test. The test built in here. This is a synonym to test, and then test has all of these comparators that you can use to test things out. And so the reason why the single bracket is more of a footgun is because it's an actual command, which means it is subject to command processing semantics. Stuff I won't go over here, but it is a little bit trickier to deal with. It's not as intuitive, and so we bash resources tend to prefer to recommend the double bracket syntax instead. But glossing over all of that, what we want here is -n $1. -n is the flag that says if the argument is non-empty, then this returns true or returns success. And we can show that here. All right, so we do a double bracket here. Remember, it is basically a command. We can do -n, and then we have the empty string. I have something here that tells me what the exit code is. In Bash and the shell in general, exit code 0 means success and anything else is failure. It goes all the way up to 255. 1 tends to be a general catch-all for failure. And so you'll see a lot of commands output 1 for failure. So the empty string here is not empty. So that's why this fails. But if we have a non-empty thing here, then it passes. In my case, if it's success, I just don't output anything. But the exit code of the last command that was run is available in the special variable called $$ question mark. So if you ever need to, you can always inspect it there. And actually, you'll find that a lot of scripts will do something redundant like this, where they do maybe not specifically this test command, but say, well, I mean, let's say they ran the test command as test. Sometimes they'll do this, and then they'll do if, let's say, question mark is equal to 0, right? So you're explicitly testing the contents of the question mark variable and testing that it is equal to 0. In the case of if, you don't actually need to do that, because if takes in a command directly, you can just replace that with the command itself. And if will take the exit code of that and treat that as whether it's passing or failing. And that's what we're doing here. Our double bracket command is our command. It exits with 0 if the condition is true, and exits with non-zero if the condition is false. So we want to say that if the command is, or sorry, if the file is passed in, then let's say we set a variable called inFile. InFile is equal to $1. Else, inFile is equal to the special file called dev/stdin. So Bash has special device files. stdin is for standard out, standard input. You also have stdout for standard output, and standard error for standard error. I think I'd explained this so last stream or something. But commands generally have 3 standard streams: standard input for input, and then standard out and standard error for output. Standard error, as the name implies, is generally used for errors because standard out is meant for things that you can parse, and you don't want errors messing up that parsing. So then we can say that instead of $1, we can do $inFile here, and then this should give us the flexibility to do either this or this. And strictly speaking, we don't actually have to initialize this variable here. it's just good practice to do so. So if we left this off, this is entirely valid. Bash won't complain. It'll just create the variable. But it's good to make sure that all your variables that you are using in the script are visible, so that it's a lot easier for debugging. So now we're going to try that out. Bin cat to start with the file case that we had that we know works, like so. And then we'll see if we broke the other case where we have stdin, standard input. And we're still okay. Looks like we're still okay. Okay, so now let's run the test suite and make sure everything else runs. And there we go, we have passing tests. Anyway, that is a commit, so we can do git add-p. Read one file from command line. From argument, actually. Okay, we're gonna push this. And so for those of you who may have come in late, the repo is in the description on YouTube and pinned in Twitch. You're very free to follow along, and as we make commits here, I am pushing them up to the repo so that if you came in late, you can just look at what's in the repo and start from where we are now. Okay, so we look at the man page again. We see that with no file or when file is dash, read standard input. This is a fairly common convention in Unix commands, where if you're expected to give a file, you can often provide dash instead, and that tells the utility to read standard input. But what happens with ours? We try to do bin cat dash. It fails, says no file, no such file or directory. And that's because we need to recognize the dash specially. And so we can make a we're gonna write a test first for this. Reads cin for dash. And so we can say dash, and then we can feed in this file as our standard inputs. So that's our test setup here. We expect this to fail. And indeed it does. With the same error that we get, no such file or directory. Kind of block it here, but you can see that. So what can we do here? We can say that we can add another condition here, where it says that if the file is dash, then we set the in file to standard input. Otherwise, if it's not empty, then we do the same thing as we did before. Otherwise, if it is empty, then we set it to standard input. So we can do that if $1 is equal to, actually for strings I think you use the equal signs here, is equal to dash, then in file is equal to dev stdin. And then we want to turn this into an else if. And so the way we would do this in bash is not else if like this. It's actually elif like that. I know a couple other languages do this too. So we can test this out, see if it works. In cat dash, and so we do indeed get a reading from standard input. And then just make sure that our other stuff works. So like license, for example, we get that. and then we'll let the test cases, or the test suites take care of the rest of the cases. There we go. Can we refactor? I think we can. Because then we can say that, because we do have two dev SCINs here, right? We can collapse that into maybe one case. We can do that using an OR compounder. I don't know if anyone uses the word compounder, but I think that it explains the concept nicely. So if you remember that the double bracket here is a command. One way that you can create a compound command is to use this OR operator here. And it says that if the first command fails, so x was non-zero, then run the second command. And so in this case, we can say that if we can do the negation of this condition here. So if the if $1 is empty, that's what it said here is 0. Then we do SCIN, and then we can, because we are left with no more conditions, we can just do the else here, get rid of the rest of it. So now reading this command, we have if $1 is dash, or if $1 is empty, so we have no arguments, then we set our input file to STIN, standard input. Otherwise, we set it to whatever the argument is. All right, so now we run the test suite just to make sure that it still works. And indeed it does. And then this is a commit. Commits -m recognize dash for standard in. Okay. What else can we do? If you remember, cat does have does allow for multiple files. So we can do cat license cat readme. Let's use the actual cat here. Like so, right? We get the license text first, and then we have the readme text afterwards, concatenated together. And so, if we try that on our utility, that doesn't work because we only recognize the one file. If we try license to readme, we only get the license. In cat, we only get the license. We don't get the readme. Alright, and I need to push this. By the way, hopefully it's still being clear so far. Everyone's following along. But if not, if you have questions, now is the time to ask. Or any time, really. Take a drink. No, do not do that. Okay. Right, so multiple files. So you remember that we do have $1, $2, $3 for our command line arguments, but we want to be able to support any arbitrary number of files. We don't want to just have restricted to just 9 files. So for example, we have the real cat, and we pass it in. This is 4 as 5, 6, 7, 8, 9. Right, it works fine, and then we can give it 10, and we give it more than 10, and it'll still output the license file that many times. So what do we do here? Again, we can put it into another loop. There is a special variable called $@sign. This is effectively an array of all the arguments that are passed into the command line. And so we can loop over this array, and yeah, so we can loop over this array, and then we have we can do something for every iteration of that. The way you would want to loop over this array is to use the for loop. And then the syntax of this is some sort of variable name. In this case, we can call this file in $@sign. And then in the same manner as the while loop, you use do and done to open and close the loop. And then we can stuff the rest of this in here, into this for loop. And then we can change $1 to file, because we're no longer working on raw arguments. And we're now working in the we're letting the loop deal with the arguments for us. And so we can actually bring this one in too. But we'll leave it out just so that we know that it's down there. Variables in Bash are global by default, so you do have to be careful about that. In this case, nothing else uses infile, so it's not really a problem. But do be mindful of where your variables are and that you're not accidentally overwriting something else. We will be looking into how to encapsulate this later. Okay, so now we have this loop, and actually a little tidbit here. If all you're doing is looping against the @sign or all the arguments, you can shorten this to do for file, and the in @sign is implied. Sometimes it's preferable to be a little bit more explicit about it, but if you want something more concise, then this is certainly an option. Okay, so let's run this, and we do expect to see that if we have multiple files, I should have written a test first. Reads multiple files. Call this in one, and I'll actually make this in 2. In 1, and then we have in 2. So now we're specifying multiple files on the command line here, still moving things to standard out to our out file. And then we have this diff here. We're actually going to need to create something else. And now this is where we make use of our fixtures, I think. Actually, no, this is probably still fine. We call this in combined. So we're just setting up another file here. Where we have the combined outputs. Actually, let's call this expected. So we expect the outputs of our cat command to be the same as these two combined. Okay. So I'm going to carefully undo this so that we can see the test fail. Test cat bats, and we do see that 1, this broke, and then 2, Actually, no, I think I went too far. I went too far. Because that is this bit here, so this is still okay. Yeah. Okay. I mean, a test suite is very nice. Okay, yeah, so this is what we expect. The read multiple files case fails. And so, what happens if we put in the for loop again? We should expect to see this pass, this part, because now we're looping through all the files. Actually, we're going to add a third one there, because having 3 is always nice. I'm just going to copy this one here. Call this in 1, in 2, in 3, and then we're going to copy this, and then we're going to say in dots with expecteds. Okay. We're going to add the third file here, testdir slash in3. That's that. And then the rest should be fine. So we should still expect to see it fail. But we also see other things fail. And that's... We are seeing the... So this diff here says that our first file is empty. And why might that be? And the reason that is because if there are no files, then what it's saying here is that if there are no files, then we just don't run this loop at all. Nothing happens. So if so if there are no files, then we don't run this loop, but we do actually want it to run. We want, if there are no arguments, we implicitly want it to have the argument that we want it to have the dash. So if there are no arguments, we want to read standard input. One way we can do this is we can special case this, so we can do an if. So say if $hash here is the number of arguments that you get from the command line, equals 0, then we can take this and do stuff with it. Another way we can do it is we can force set the arguments. And so we can do that with, I think it was sets? I think it was set. I'm gonna make sure. Because the way I did this before, I did this differently. But we might be able to, this might be a slightly better way of doing it. Yeah, so set or unset values of shell options and positional parameters. And so this means that if whatever you set here now ends up being the parameters of the script. And I will demonstrate that by doing something here. So say if we have the same loop as before, for file in this, bin and bash scratch slash stream slash what we have here, stream slash sets. Let me set.sh. Sure. Commodore 256, welcome in. I've noticed there's a lot of people from China and Vermont here on Twitch, so many usernames end with CH and VT, and a lot of people from Vermont are Uber drivers, as indicated by vtuber. That's interesting. Never thought of that. Maybe that's why there's so many VTs. Actually, there's I remember there was some this discourse a couple years ago, where was it like PNG tubers or anyone with like a virtual character, like not their IRL self, had considered themselves VTubers even though they don't really fit the definition, and so there are a lot of what is it? A lot of their names end with VT just because they're not their IRL self. So that, I guess that accounts for a few other people too. Uo comes to mind. Uo, I think, is a bit of a special case because he does actually have a VTuber model. It just the nature of his streams means he can't really use it. So he's a bit of a special case. I think I consider him a VTuber, but only barely, and only because of because of circumstances. He is also in the VTuber community, and is in the culture. So, I'm willing to. So if he doesn't strictly follow the definition, I think I'm willing to give him that exception. Let's give him a shout out over here on Twitch. Shout out Uo Slab. I remember an exchange he had about this that ended with VTuber derogatory. Yeah, that sounds like him. He definitely does. He definitely is a little bit ironic about these kinds of things. I think corpse CH counts if you don't need an animated model if your character is a corpse. Yeah, that's another one too. Corpse doesn't. I wouldn't consider corpse as a PNG tuber, weirdly enough. I can't give another shout out yet because there's like a 2-minute cooldown or something. But yeah, corpse is a VTuber who doesn't talk, and their model, as far as I know, isn't animated. I haven't really watched much of their streams, but I don't know. I still consider them a VTuber. And chill streams, yeah. They also, I think they also review music with other people on occasion. Coincidentally, one of the times that I was looking to maybe consider reading them was the time that they were, what was it, reviewing music with Uo. So that's a crossover I didn't expect. Alright, just lining up that shadow while we're here. Is this correct? This is correct, okay. Yeah, I think I have to wait 2 minutes before I can do another shout out. But, okay, going back to this one. So sets, we get rid of all of this stuff. We do, say, echo file. And we do sets, and then A, B, C, D, right? So what we're trying to show here is that set will overwrite the command line arguments. Stream slash what did I call this thing? Set.sh. Permission denied chmod plus x. So to be able to execute a script, you need to give it execute permissions. Windows for some reason has execute permissions on by default, so that's why you can run anything there. But on Linux, it's not on by default, so you do have to give it explicit execute permissions. And so we can do this, right? We get ABCD here. But that's with no arguments. If we do give it arguments, say 1, 2, 3, 4, 5. If it didn't replace the arguments, then we would expect to see 1, 2, 3, 4, 5. But instead, we do see ABCD because this does replace the arguments. And once you replace it, it's gone. The original ones are just gone. So you have to be careful about where you do this. So I've had trouble learning programming, don't know what to do. I don't know how to read that. Learned for 10 years and still can't code a thing. It's I think it's a lot easier if you try to if you have a project in mind, a problem that you want to solve, and then you can try to learn what you need to do to solve that problem. So for example, I don't know, maybe you have to rename a bunch of files a lot, very often. Then you can learn how to script things on the command line so that you can do that kind of renaming. Or if you want to automate something that you do, let's say you have a timer, and you use timers a lot, and for some reason none of the apps that you want to use are suitable for what you need. And so what you can do is, and you want it on a web browser for whatever reason, you can learn like JavaScript and other web technologies to get that up and running. Why not a cron job? I mean, I'm just giving arbitrary examples here. Cron job could work for for your example if that's that's the solution. But yeah, projects that you're interested in and beginner projects don't intersect. Yeah, that is a very valid and very fair point. I don't know. I think it's just a matter of maybe think smaller, and then if there's anything that you're interested in, you can try that out. There's also another thing you can do. GitHub, good first issue, I think. If you're interested in if you don't have any specific projects or problems in mind, one thing you can do is you can search through for good first issues on GitHub. Usually an issue will have a label on it that says good first issue, and if any of these look easy or desirable to you, you can try like take a stab at learning what you need to fix this, and then just try to fix it. Struggle fathoming accepting abstractions that don't have physical metaphor. Like, it feels like tutorials are telling me to talk to the tooth fairy. Yeah, abstractions, I think, is something that programmers do a lot of abstractions, and it's. I think there's a saying: it's abstractions all the way down. So it is something that you have to become comfortable with, and I think it's helpful to abstract yourself away from physical concepts, physical metaphors. But that does take a bit of. I think once that clicks, it makes it a little bit easier. But yeah, I think it's more of conceptualize what it is that you're trying to do, and then I don't know. It is a little bit hard to explain. But yeah, conceptualize what it is that you have to do, and then try to find approaches. Like different kinds of approaches to do that kind of thing, because that's what an abstraction basically is. It's just another way of doing the same thing, and often it enables an easier way to do other things that need that kind of functionality. All right, so for this one, we've proved out that set here, in this case. This double dash here just says the rest of these are arguments, but we can use this to say that if we have no arguments, then we set the default argument to dash. So if $hash is equal to 0, then we set this, and then we end the if statement. I know we can give this a comment because it's not entirely clear what we're trying to do here. Comments in Bash and other Bourne shell compatible shells start comments with the hash sign, and they continue until the end of the line. So they're single line comments. There are no multi-line comments. So defaults to reading standard in. Okay. So that should be good. And we can do again bin/cat, and we do see that we get standard in here. And if we try to cat out the license file and the readme, we still get that. And the same thing is if we do have the license file and then also dash, and we should expect to see the license file and then read stuff from standard input, like so. Great. Entire reason for being into technology is taking apart home entertainment appliances and being under the impression that college-educated adults can have a complete understanding of a whole device. Seeing physical, tangible components, that magic words on a screen violate my love of technology. Curiosity hinders progress. I hate that. Yeah, to be honest, hardware and software are fairly different things. And a lot of technology these days are very, like, for example, cars. They used to be very mechanical with no software parts, but these days I don't know if you can properly service a car to its fullest extent without at least knowing some of the software. And that's true for a lot of things too. We're getting embedded microchips everywhere, and like, because software is very flexible in terms of what you can do with it, whereas hardware is a little bit more restrictive, even though it can be a bit more optimized. Nobody buys an entertainment appliance that one well-trained adult can have a complete understanding of. Yeah, it is definitely difficult to have a very complete understanding of that kind of system. Especially the smart appliances now, like smart TVs and whatnot. Like a TV used to be, you get signals from the airwaves, and then it just converts those signals to an image on the screen, but now there's a lot of software behind it, and it's basically just another computer with a very large screen. So you can definitely learn, bits and parts of it, but I think it would be very difficult to understand to have a complete understanding of every little detail. Okay, I think enough time's passed. We can shout out corpse now. So yeah, so this works now. And I think that's a commit. Oh, actually, there is one more thing that I want to point out here. There are other comparators that we can use in Bash. One thing that's useful here is that if your variable is numeric, then what you can do is you can use the arithmetic comparison instead, and it makes it a little bit more natural. Arithmetic comparison would be using the round parentheses here. I think it would be something like this. Or actually, I think we can do that. So we can test this out here. If 0 is equal to... So if 0, then that's false. Yeah, so this works out like it would in say something like C. So any non-zero here would be truthy, so that we end up with success, and then a 0 here would be falsy, and so then we get failure. I think we can put a thing in here. No, that's not what I want. We can negate the command here. So here the exclamation point is if the command had succeeded, it actually is a failure, and if the command had failed, then we actually consider that to be a success. With all that context, what is your advice? Yeah, the exclamation mark is basically not. So yeah, I think don't expect to be able to learn everything, because even if you stick to just software, just hardware, you're not going to be able to learn absolutely everything. Like, for example, if you're in hardware, CPU is hardware. Good luck trying to understand that. It's all magic if you at some points down the line, at some level of complexity. But learn whatever interests you. If you think that you're interested in software, then figure out what parts of software you do want to learn. So that could be embedded, that could be web, that could be systems, a bunch of other things. Or if you're interested in hardware, have a look at that. Get maybe an Arduino or something and play around with things. Hey, being punished for your curiosity. I don't think being punished is the right way to look at it. I think it's more of, yes, there is a block there, and it is a wall that you have to overcome. But not understanding something it's not failure. And it's certainly not a punishment. It just means that you have not learned this thing at this time, and it is potential for you to learn that thing if you wanted to. Right, so it's more opportunities for growth rather than setbacks. It does when I'm giving a text editor and a compiler, and like, how does the interdependent stack that makes this work? So there's a point where, and schools do this all the time, right? There's a point where you have to accept that this layer of complexity is too much for you to handle at this time because you don't have the requisite knowledge, and so you just assume that this portion works the way it does, and you don't think about it. And then you think about the stuff that's on top, that's built on top of it, that you can understand. And then once you have a good understanding of that, then you can start digging deeper into things. So let's say, for example, schools teach that there are 3 states of matter, like solid, liquid, gas. That's not true. It's an oversimplification that is relevant to the level that grade schoolers are at. But if you really dig into it, there are 4 main states of matter. There's plasma too, and then you get into exotic things like Bose-Einstein condensates and a whole other, like, whatnot, neutron degenerate matter. A whole lot of whatnot there. And if you pelt the grade schoolers with all that at once, they're not going to learn anything. So you start with what you can handle, and don't try to bite off more than you can chew, and then just work your way down. You say that you can't just leave it to faith, but as humans who are very limited in our capacity to understand things, there eventually has to be a layer of faith. How does GCC work? How does glibc work? How does ASM work? How does CPU work? I just want completionism, and it's very natural for us humans to want to understand things, and that is definitely something that you can like. These are all software systems built by people, right? So these are all things that you can gain an understanding of eventually over time. But it may take a long time to actually to pick that up, right? Learning how a compiler works, how to build a compiler, that is a whole university course even. That's not to say that you need to take a university course to learn it, but people do study these things. For me, it's enough for me to know what these are and how they interact with the system, but not necessarily, I don't necessarily need to know like how they're built, or like what the theories are behind it. So it's like driving a car, for example. You can drive a car without having to know how it's built or like how the specific parts interact with each other. You just need to know enough that you can drive the vehicle. So like turning the steering wheel turns the wheels, and by doing that it turns this way. You don't necessarily have to know that turning the steering wheels, nowadays I think it's all drive-by-wire. Actually, I don't know. The steering wheels might actually be connected to physical things these days, but so like pushing on the gas activates some sort of electrical system, like computer system, that ignites the. I should not be talking about cars. I'm not qualified for this. But yeah, people many collectively, and because it took all these people to build these things and all that, you as one person, it's going to be very difficult to collect everything that everyone knows. But that's why we have encyclopedias or rather knowledge bases like encyclopedias like Wikipedia and all that. So where we can collect all this knowledge into one place for others to look at and reference later on. So yeah, browsing Wikipedia is a great way to learn too. But yeah, when in consuming context, let things be as they are, but as soon as I'm giving tools, that activates toxic curiosity. Now, I think framing it as toxic is also not a good way to look at it. But yeah, as 539 says, it sounds like your educational eyes are larger than your stomach, and curiosity is good. It drives you to learn things, but I think you also have to understand that your limits, that you do have limits, and that you can't immediately go out of those limits. And yeah, there is no aspect of this that can't be learned, just not all at once. So it will take time, and you can't, because if there's something that you could learn, like if you were able to learn everything like right now, then it's very easy, right? Everyone can just know everything. But that's not the way we are. We take time to learn things. And that's where streams like this come in too, right? This is a, I don't know how many of you viewers know how to use Bash, but even if you do know Bash, there are things here that you could maybe pick up that you didn't learn, that you didn't know before. And so, even me, like you've seen me like test things out because I don't specifically remember how to do these things. But I have the documentation available to me for me to jog my memory and remember, and even learn if I didn't know it before, that these things are things that you can do. And so it's a matter of just it's a lot of just following the path of learning and following the trail of things that you can learn, and then doing that in a way that gets you to learn what it is that you want to learn. But it is a process. It is something that you do have to take the time and effort to put in, because it's not something you can get all at once. But I hope that helps. And this attitude too, where I think that you want to learn everything and know everything, that's also not something that's very easy to get out of, and so that too will take time to overcome. Okay, so yeah, I was talking about this here. So this is not, and then this is the arithmetic comparison. Strictly speaking, I guess we don't need to do this, and I think actually we can have this in here too. So if we do that, for example, yeah, that also is that is also success. Now, is it clear? Is it clear if we do this? Not really. I think we can probably do this instead. Zero is equal to 0. That. And at this point, is it really worth using the arithmetic operator? I don't know. But we're putting it in here just so for exposure's sake. I had an impression that tech equals consumer macroelectronics. You can build any device sold at Sears from parts from DigiKey. Liked at a 50-year-old radio electronics magazine, there was a kit for one person to build technologically relevant device. 25-inch color TV. Nothing as relevant today as a 25-inch color TV that was in 1974 that one person can make down to the bones. Yeah, I mean, as technology progresses, as they get more complex, it's definitely a lot more difficult to build your own. you will have to, at certain points, take parts that others have built and then use them, trust that they work, and then use them as part of the larger work. For example, taking software, like a software example, AI is all the rage these days. But would I know how to program AI and all that, like as an AI system? No, not really. I mean, I have very basic knowledge of how it works, and what the ideas behind it, but I neither have the requisite knowledge. Well, I don't know about that. I don't have the time or the desire to actually learn that kind of stuff. But what I can do instead is I can take the library that somebody else has used, and learn how to use that library, and then use that to create a system that is AI powered. But I'm typing this on a keyboard that I built more or less from scratch. Yeah, and there are things that that you can do that are simple, like keyboards. Like keyboard building is a very popular pastime too. So there are definitely things that you can build that are still relevant, but perhaps things like TVs, where there are a ton of things that have been added to them these days, maybe those are no longer as easy to build. AI is all black box and have fun debugging data sets. Yeah, I'd say the field is still in its infancy, but actually it's been around for quite a long time, for decades. But all the new stuff is definitely newer, I guess. It's a keyboard, something mundane. But to be fair, the stuff that were buildable back in the day were, speaking relatively to what we have today, are fairly mundane. Right, even in color TV, compared to smart TVs, right, it's very simple compared to what we have now. That's not to say that they were bad, and that's not to say that we shouldn't have smart TVs now. But like, things change, as 539 says here, new things are new. And with as technology progresses, complexity is added, and yeah, things do tend to get more complex and are harder to build. That TV gave me joy and comfort, a keyboard doesn't, and that's fair. Like, different things give everyone different joys, and what like for another person, a keyboard can give them joy, while building that kind of TV doesn't. But for my case, right, Arch Linux here, I'm running Arch, by the way. The other day we had actually installed Arch Linux in a virtual machine, and some people prefer to do that. All right, some people prefer to build out their system, knowing what every little thing does. But some other people will just like things to work and will install a prepackaged distro like Ubuntu. And that's fine. Right? If you want to learn how your system works, or how the individual components of whatever you're building works, then use something and follow something that will allow you to do that. But at the same time, know that when you do that, either you're missing out on some of the complexity that other people have built, or there is going to be a lot of stuff to sift through to completely learn everything. How do you know they're not selling your data? Well, you don't. Not unless you replace the firmware. And that's probably something you could maybe do. I'd expect the community to have that worked out for the most part. I don't have a smart TV or any TV at all, so I can't give any recommendations, but something probably exists. Yeah, I'm personally not a big fan of smart TVs myself. It'd be nice if I ever do get a TV that maybe it isn't smart. But yeah, I can understand if a lot of the options are limited. Only use CRTs. Well, that's certainly certainly a stance. My family did used to have a CRT back in the day, and you still can use one. Although I think you have to have adapters these days to make sure that you can still plug in things like HDMI and the digital TV and stuff. Looking at OLEDs, yeah, I mean I don't really have much much opinions on TV technologies these days. LG Smart TV is lobotomized, not connected to the internet, and permanently set up as just another monitor for my PC. Yeah, that's the way to use it too. I don't know about using TVs as monitors though, but I suppose they are still a display. Unless the PC is specifically for displaying things on the TV, so used as a TV. In which case, sure, I understand that. Or you're using it for things like, I don't know, my workplace used to have a few TVs where we would permanently display like metrics and charts and all that. Okay, so we're keeping this just for the sake of keeping that. Fourth monitor, basically main PC doubles as an HT PC. I don't know what that stands for. Add P. Defaults reading STN with no args. Home theater PC. Okay, yeah, that makes sense. I use an SD CRT as a monitor, good enough for games. Well, certainly, yeah. I think games are a big use case for CRTs because of the low latency. I guess related to that, the CTWC, the Classic Tetris World Champions. I think I heard that preliminaries are starting soon, and that championship all uses CRTs because of the latency, I think. Normally that implies jellyfin sets, but my Firefox and MPV are good enough for me. Yeah, I don't understand what the hype is about media servers, but maybe I just know how to set all these up myself. Because yes, you can set up a media server and have it transcode and everything, but also I can just have files on the computer and play with MPV. Yeah, I don't know. I guess it can be useful for like if you have the server elsewhere and not directly connected to your computer. Like I know I have one friend who has like a Plex server set up on his machine, and he shares it around to a bunch of people over a zero-tier network. And so in that case, sure, I can understand that. But also, you could also just make the files available, and I could just play with MPV. Yeah, I don't know. Maybe it's a convenience thing for people who aren't as well versed in the technical options. Okay. Back to this. Where were we? So now we have... Actually, I gotta push this. Test cat bats. Oh, wait a minute. Hold up. No, that doesn't actually work. I should have tested this before committing. We broke something. Why did that break? Reads multiple files. Test 1, 2, 3. 2 outs. But instead what we're seeing is that we are seeing the same file twice. Why do we see the same file twice? This is a great opportunity to show off Well, hold on. That's help. You have X. Yeah, okay, trace. So bash has this trace mode. So if you do bash X and then you run the file, in this case cats bin/cats license and readme, and then say I don't know what else, bin cats. It goes through the entire. It runs the file, and then it tells you the lines that it's running as it's running them. In this case, it's going to be kind of difficult. Set no wrap. Right, so we go line by line here. From the top, we have in file, sure. If 3 is equal to 0, which it isn't, we skip that. For file in the arguments, the license. If license is this, it is not. So we move on to the next command. If license is empty, it is not. So we skip that. So we skip to this one. In file is the license, and then ifs equals empty, and then read our line. That's that. Print f that. So we skip all that, and we'll go through the lines of the license file. And then for some reason we keep the same file. That is very odd. Okay. We're going to do a little bit of debugging here. I'm going to echo out the contents of the arguments here, the arguments array, and then we're just going to exit so that we don't run the rest of it. License readme bin cat. Okay, so from that point we have it, but after this point, do we still have it? We still have it. Okay. So then over here, echo file. What is file? And just so we make it a little bit easier to see. We cat these three files. We're gonna grep for that arrow that we got, so that we only see that bit of output. I am very confused. So what this is saying, which is what we expect here, right? The for loop loops through all the files we get. So license readme cat in order. Did I forget? Aha, here it is. Because this is saying that we're taking the first argument that was given to the script. We don't want that. We actually want file. Okay, so this should work as expected now. Okay, great. That's what we want to see. So we have the license file, then we have the readme, and then we have this file here. And we do our test cat, and then all our tests are passing. I would like to amend the previous commit, but I've already pushed it. I don't know if anyone has pulled it down, so I don't want to accidentally mess up their repos. Git add -p. We don't want to commit that. Git add -p, by the way, will go through all the changes that you've made, and then prompt you one by one if you want to stage those changes, and so you can have a piecewise commit. And this is useful for making sure that you are committing what you want to commit and nothing else. And so we want to commit this fix issue, or properly recognize multiple files. And in this case, we want to add a little bit more explanation to what this this command was, or the change was. A $1 was left in the for loop that should have been replaced with $file. This caused the scripts to always take the first argument rather than the current file in the loop. Okay. And then we format that with -e, so we can go into Vim and then wrap the lines at 72 characters, I think it is. Okay. Then I can push that up. Push. Now we should be correct there. We're coming up to the 2-hour mark. My voice is actually mostly fine, interestingly enough. Got a dip. Good night. All right. Thanks for dropping by, and good night. Yeah, we might end soon-ish because I do have another stream tonight. We are going to be playing Tetris 99, right here, because there is a new event, and I want to make sure we get that theme. But for now, is this everything that I wanted to go put in? We can continue this another time, actually, because there were more things that I wanted to do here, like show off how to recognize flags. Because if you look at the man page for cat, there are a ton of flags here, but we don't support any flags right now. But this is fairly good for a very basic cat, and I think this is probably a good place to stop, to be honest, because cat has very basic usage, right? Cat with no arguments reads standard inputs and echoes it out. Cat with one argument, if it's dash, read standard input. Actually, we should be using our cat. Alright, so no arguments, we get that. Echoing out standard input. One argument, if it's dash, then the same thing, we echo out standard input. If it's a file, then we cat out the file. If it's multiple files, we concatenate both files. If it's multiple files after that, then we still concatenate all files. Let's do more than 10 just to prove that this does work. Probably plenty. Okay, that still works. If we have a dash in the middle, then it does all that, and then it waits for standard input, and then it cats out the rest of it. And so, as far as the cat implementation goes, this is if we ignore all the flags, this is actually pretty good. And also, just to test that we still have bin cat. Right. We still respect all the white space. So in terms of this working, I think this is fairly good, and we can probably leave the flags for another time. Because I don't want to strain my voice too much, and I do want to make sure that I have time to eat and stuff before the next stream. So I think yeah, we will leave it there. The code right now is pushed up. So if you want to take a look at our progress, see what we ended up doing here, there's always the git log, and you can see what it is that we did here. And then if you want to take a stab at writing your own like supporting all the arguments that we have here, all the flags, feel free to do so. We will handle those some other time. Okay, what else is there? Yeah, so next stream will be in about an hour and a half, if I can math correctly. 11 o'clock Eastern time. I think that's, yeah, it's 11 o'clock Eastern time, so that's about an hour and a half from now. We'll be playing Tetris 99 to get the new theme, because they do have an event going on. If you're not in the Discord, link is in the description on YouTube and on Twitch. I've just put it there in chat. We'll also do it here on YouTube. These technical streams generally I do on YouTube, YouTube only, so if you are interested in these kinds of things, do consider giving me a follow there. Put that in there as well. But on occasion, I will stream to Twitch for these things, and also a bunch of other topics like Tetris here. So this, I think, then concludes our technical week. That's not to say that we won't be doing more technical content, because it is supposed to be a regular thing. So hopefully we'll have at least something next week, usually on the Wednesdays. And so with that, for anyone who's new here, thanks for dropping by. Thanks for all the follows. I am Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and we have written Bash. Or sorry, written Cat in Bash. Okay, I think that's it. I will see you in an hour and a half, but in the meantime, we were going to find somebody to raid if you're on Twitch, so stick around. YouTube, we're just going to end. Yeah, I think that's it. Alright, see you, chat. Good night. Alright, well this was an easy find. We're going to raid Clonk. He is doing, I think he's programming a game or something. This is the raid message if you would like to participate. Feel free to say hi. Clonk has one of the most interesting setups that I've seen VTuber do. And you will see once you get there. Alright. Well, enjoy, and hope to see you in the next stream in an hour and a half. But in the meantime, do enjoy the programming. Alright, bye.